Okay, hello everyone. How did your worksheet go? How did the homework go? Please, if you have questions about the worksheet, use chat. Anybody? Now you know that you have the worksheet and I put the answers, so in case you do them, you know very well if you got the right answer or not. Any questions from you guys? Okay. So I will start. The first thing I would like to talk about is comments on your quiz. Now, as you guys know that I give feedback to each one of you on the quiz. Please read, please read the feedback. Be very careful so you learn from it. So the comment on the quiz is, I usually take the question that gave some student difficulties. So it was on number 2, and I had the function f of x equal 4x squared plus 5. And the question was the following. Find all values of c such that f of c equal to 6. That was the wording of the question, okay? And the issue that we have is that what I'm asking you in this problem is to find the input where the output is 6. Right, so that's really what the question is. So a lot of students plugged in 6 in here. That's not correct because I'm not asking for f of 6. What I'm asking for are the input that gives me an output of 6. So the only way to do this problem is you're going to set 4c squared plus 5 equal to 6 and solve for c. That's the way it goes. So if we do that, we will get 4c squared. So the easiest way to solve this problem is basically isolate c squared. This is going to give me a 1. Hence, c squared is 1 over 4. And it means there are 2 values. When you square them, you get 1/4. It's the plus and the minus a half. Okay, so that was the easiest way to solve this problem, all right? I'll make a comment here. So in this problem, we have to solve a quadratic. It's a quadratic, it means the unknown is raised to the power 2. And there is no c, there is only c squared. In this way, the easiest way to solve it is isolate c squared equal 1 over 4. Now, when do we factor? And a lot of students factored very well, but I have to make a comment. When it's easy, when do we factor? Okay. Let us say I have the following problem. Suppose I tell you my function f of x is x squared plus 3x. I'm just making up something, minus 22, something like that. And I ask you find the values of c such that, let us say, f of c equal to 6. So always we do the same thing. We're going to set c squared plus 3 minus 22 equal to 6 and solve for c. Now watch carefully here. I have c. So in this case, I cannot isolate c squared. The problem doesn't work. So the only way here is to make this equal to 0 by bringing the 6 here, and you have to factor because I have a c. In this one, you could factor, but it's not necessary because you can isolate your c squared. However, here we cannot isolate the c squared because we have a c. And we factor by finding, since it's a c squared, it's a c and c, finding 2 numbers. When you multiply them, you get 7. When you add them, it's 3. So 4 and 7 are the candidate. And then you check backward, c squared minus plus 3c minus 28. So this will give me either this term is 0, giving me c equal minus 7, or that term is 0, give me c equal to 4. Okay, so that's the comment I have about the quiz. Please be careful when ask yourself, is she giving us the input, we have to find the output, or she's giving us the output and finding the input. In this problem, I'm giving you the output of 6, and you have to find it. So that's really my comments about the quiz. The rest were minor mistakes here and there that you guys should be able to figure them out. Right now, I go back to your question, and the question is section 1.6, number 8. All right, we will definitely do that. And then can you go over 2 on the worksheet? All right, so we will start the worksheet, and then after that we do number 8, and then we proceed further. Okay, so this is my worksheet. All of you should have the worksheet, and we will go through them and ask ourselves, okay, what is the rule that we have to use every time? Okay, so the first question is x squared times x5, and the question is, what is in the box? So I write every problem very clearly here, so there will be no problem. And which rule we're using? Equal x, and my question, what's in the box? So here we remember ourselves the rule that I gave you. So if you have the same base, different power, always remember that we add the power. Okay, so this is gonna give me x to the power 2 plus 5, x to the 7. Okay, after that I want your answers quickly. And y times the 5th root of x. This is x times the 5th root. It's x to which power? Quickly. Which power? 1 over 5. Now I have the same rule. The base is x. This is raised to the power 1. This is raised to the power 1/5. I add my power. Now I know this is a fraction, but it's not hard. If that's not a hard fraction, the common denominator is 5. So that's what gives me 5 over 5 plus 1 over 5, x to the power 6 over 5. Okay, so every rule we have to know exactly what we're using. Now the question is x cubed to the power 4. And this gives me x to which power and which rule we're using. I want on chat the answer 12, absolutely correct, because if you have a base and the whole thing to a power, we multiply the power. Please make sure we know very well what you're using. So 3 times 4 is 12. Then 1 over x to the power 3 is x to which power? Again, let's remind us, minus 3. Because remember the definition, O to the minus n is 1 over a to the n. Very good. Now, x7 over x squared. So we're going through that quickly, but it's crucial that you know it. So here I have the same base, crucial, different power. What do we do with the power here? Question quick. I want answers on the chat because I would like to move on. Absolutely, we subtract the power. And if you ever forget, just ask yourself, I have 7 x's and 2 x's. How many x's are left? Is actually 5 x's. So to the 5. Okay, now x3 over x to the power a half. That's again the same thing, but it's harder because the power down here is a fractional power. But it's the same. The rule is the same. It's 3 minus a half. Okay, and the exponent is always written as a fraction. We do not use mixed numbers. The exponent has to be written as a fraction. Now 3 minus a half is 2 times 3, it's 6. It's 5 halves. So that's really a fraction. That's what goes in the box. Okay. Now this, that's not the answer, but that's to remind you. What does x to the half mean? It means 2 is the root, the whole thing to the power a half, just to connect to what we've done. So what's x to the 5 halves, which this is look very bizarre, means you take the square root of x, whatever it is, you raise it to the power a half, and that's the meaning of x to the 5 halves. All right, let's do the other 3. Okay, I'll take another page. Right. So this tells me what is the square root of x squared y to the power 3. Okay. Now, as I said, we have to use very specific rule. One of the rules that I mentioned last time is that if you have the nth root, regardless which root, of the product, and that's crucial, we have the product, this we can split it times multiplied by the nth root of b. Okay, so we can split. This is the rule of x. If you have a multiplication, it is possible to split. This will make this problem relatively easy, because this will become the square root of x squared times the square root of x cubed, of y to the power 3. Now this is equal to, now I am assuming in this problem x is positive. So what's the square root of x squared? Because I need boxes here. What's the square root of x squared? Give me. What's the number? When you square it, you get x squared, absolutely x. What's the square root of y to the power 3? That's in fraction notation. Is y to which power? 3 halves. That's to the power 3. If you want, raise to the power a half. If you ever forget that, which is x, y to the power 3 halves. Right? 2 more, and then number 8 is very much along the same line. The cubic root of x squared y cubed. Again, I'm using the same rule. If I have a product, I can split. So that's the cubic root of x squared, the cubic root of y cubed. Then I'm basically there. This is x to the 2/3. Cubic root of y cubed, it means which the number when you take to the power 3, you get y to the power 3, it's y itself. Right, now we finalize with the last one. What's the cubic root of x to the power 5 over y squared? Okay. Now, again, one of the rule of the exponent is that if you have a over b is the nth root of a over. So if you have division, we can also split them. And then once we use this, we can proceed slowly. So the first one is x5. The second one is y squared. Now, with this in mind, this is equal to the cubic root of x5 is x to the 5/3, and the bottom one is y to the power 2/3. All right. At this stage, I'm going to rewrite it like that. So it is like times this, because that's how we multiply fractions. So it's the product of the numerator over product of the denominator. Why did I do that? Because I am almost done. 1 over that is to the minus 2/3. Okay, please ask questions on chat only concerning the material. No other questions on the chat are allowed. Right, now, an important remark, very important, that when you have the nth root of the product, it means you're multiplying, we can split. Dividing, we can split. However, and that's very important, if you have a sum under the square root, you cannot split. Very important. You cannot split if you have a sum. Let's take an example. That's the easiest way to convince you. Suppose I take, let's take some nice number. I take A to be 9. That's a nice number. I take B to be 16. Another nice number. What this is equal to what? That's the square root of 25, which is 5. However, if I split, what do I get? 3 plus 4. I get 7. Absolutely different. So be very careful. If you have a sum under the square root, you cannot split the sum. You can split the product, but you cannot split the sum. Product allowed, division allowed. Sum is not allowed. It doesn't behave well under the sum. All right. Any question before we proceed? Now I'm going to look at number 8 from the book, and then we go on to the new material. So number 8 is the following. We have a function. It's along the same line, but now we have a function that if you give it an input x, the output is x to the 2/3. Okay. Let's remember what this means in terms of, in the language we understand easier, but we have to be familiar with this. This represents the root, and 2 represent the power. All right, so that's really what it means, because it helps us really interacting with those. So the first question is, find, I'm sure you guys didn't have f to the f of 27. It means 27 to the 2/3. Now to compute this, it's easier for me to go to the nth root because it's easier for us. So this is the cubic root of 27, the whole thing to the power 2. Now when I rewrite it this way, I understand. The cubic root of 27 is, which number to the power 3 gives me 27? 3 squared is 9. 9 times 3, that's a 3 squared, equal to 9. Okay. Let's do f of -1 very quickly. I want the answer. I want answer on the chat for f of -1. 1, do we agree? Because that's the cubic root of -1 to the power 2. Which number raised to the power 3 is -1? It's -1. But they want me to square it. +1. Now the last one, what is f of -8? And that's a B, I think, and that's my C here. Again, so it's -8 to the power 2/3. Once I write it in this format, I am ready to go. Which number to the power 3 gives me -8? It's a -2 square, which will give me a 4. Okay. Now to the more symbolic way. So this is with just plugging number. Now in the more symbolic one, and this will be based on the worksheet I gave you. Suppose I want symbolically to simplify this expression. What does this mean? Okay, that's the output to the power 2/3. All right. Now we can proceed 2 ways, but I will proceed in the way that I think it makes more sense to you. 3 of -8 t to the power 3 z6, the whole thing squared. Right? And now let's do that. As I said a minute ago, because it's a product under the root, we can split, meaning that's the cubic root of -8 times the cubic root of that times the cubic root of this, but the whole thing is to the power 2. All right, what did you guys get? Anybody? Anybody? Let's do it very slowly. So the whole thing to the power 2. Okay, you help me out. What's the cubic root of -8? I want quick answers so we can finish them. What's the cubic root of -8? -2. Times. What's the cubic root of t to the power 3? What's the number? When you take it to the power 3, you get t3. It's t itself. I'm multiplying. Okay, cubic root of z to the 6. What's the number when you take it to the power 3, you get z to the 6? z square. So here, that's exactly z square. So, or you can think about it, if you want to think about it, if you ever forget z square, which is I hope you don't, if you ever forget it, you know, you write it in fractional exponent. That's 6z6 to the power a third, means z to the power that, which is z square. So if you ever forget this one, it's just z square. Now I'm at to the power 2. Now be very careful. The power 2, it means each term to the power 2 because we are multiplying. So this is minus 2 squared times t squared times z square squared. So finally, I will get a 4 t squared square square z. So the term is quite simplified. Please ask questions if you don't understand before I move on. Don't let me move faster than you. All right. Okay, 2 more and we proceed. So, which one? E. F of the cubic root of x. So this is a bit nasty. Okay, let's have the cube. That's the hard one. What is this? It means whatever you have to the power 2/3. Okay, that's the hard one, actually. Anybody was able to figure out some simplification for it? I'll give you a minute. I want you to write this using fractional exponent. Okay, and then I want you to tell me this become x to which one? That's the only hard one. Let's see. Yeah, anybody beside Kaylee? Kaylee, you're right. I mean, now Kaylee has the answer on the board. Okay, let me walk through what I think she did. What's cubic root of x? X to the third. The whole thing to the power 2/3. Right? Now this gives me what? It gives me what? Remember the rule that if you have a n to the power m, you multiply the power. And that's exactly what we did. We have a third, 1 power times 2/3. And how we multiply fraction? We multiply the numerator, 1 times 2. We multiply the denominator, 2 times 9, x to the power 2. So this is hard, but it's nice application. That's the end of that. Now the last one, and I think we finish with that. F of t to the power 3 plus. Oh boy, whenever there is plus, there is a plus. That's what? It's cubic root of t to the 3 plus f3 square. Okay. What do you think I can do with that? I'll give you a minute. Do you think I can simplify this? Okay, nobody's saying anything. It means you're right. Okay, what's the situation? T squared S squared. No, I don't know where you got that from though. Remember, it's a plus. Plus, plus, crucial. Be very careful. It's a plus between them. It's not a multiplication. And what did I say a minute ago? You cannot, if you have a plus under the root, that is, you cannot split the plus. You cannot split the plus. Why I am saying that? But I'm saying that for the following reason, that here, this is not the cubic root of t cubed plus the cubic root of s cubed squared. I cannot split that. And that's why the problem is really merely to really bring this up. There is no way I can split that. Is absolutely wrong. So it's not t plus s squared. This is not the answer because I cannot split if I have an addition. We split if you have multiplication. We cannot split if you have addition. What does this mean to this problem? It means that there is nothing I can do. That's the answer. I cannot move any forward. Because I cannot split, there is nothing I can do. It is what it is. So the answer is exactly this one. You cannot move any forward. And the point behind this is to tell you that if you have a sum, you cannot split, period. All right? So please be very careful with this addition. Another one, before I move on to the new material, it's actually not hard at all, it's easy. Another remark that also I would like to make is the following remark about algebra. If you have the following quantity, a plus b to any power, let us say even 2, the easiest power. This is also not a squared plus b squared. Okay, so we cannot split. If we have a sum here, we cannot split it this way. And let us see why, not because I said so. If I take a plus b squared, this is a plus b times a plus b. It means if I distribute, I get a squared plus ab plus ba, which is the same, plus b squared. So it's definitely not a squared plus b squared. So it's a squared plus 2ab plus b squared. So those are the very two common mistakes that shows up a lot. If you have a plus, a sum, it can't be split under the root. If you have a sum, a plus b to a power, it's not a square plus b squared. Also, it's not. That's what this answer is. All right, any other questions? Okay, so today we're going to cover 1.8, which is, it's going to take like 10 minutes with us, I hope. And then 1.9, which is also, both of them are easy sections. So 1.8 is nothing more than another way of writing a function. So section 1.8 is called function concepts. It's actually what we've been doing, but it's sometimes people write function in a slightly different way. So that's a different way. I will keep this for a while here. A different way to describe a function. So I'll just elaborate by an example. Okay, the way in this book we've been talking about function is it's a rule. And let's say this. Let f be the function that assigns to each time t, let us say on September 7, yesterday, the temperature in Chicago at time t. So here I have a rule that every time, so that's my rule, it's my f, you give it the time of the day, and my rule gives me the temperature at this time. Okay, so this is really my rule. So if I tell you following this, so suppose I tell you f of, let us say 8 is 8 a.m. equals 65. It means you're understanding that at 8 o'clock in the morning, the temperature is 65 degrees. Okay, so that's really the rule. All right. So the input, that's the input here. And that's my output. Now, sometimes the same function, we describe it in another way. So another way to rewrite this is as follows. We say, let f be the function that gives the temperature in Chicago on September 7th, gives the temperature as a function of time. So what does it mean? Give it as a function of time. What does this? The temperature as a function of time. This is another way to say, let f be the function that is assigned to the time, the temperature. So the way we write this is always you write it as the output is a function of the input. So sometimes you don't write in the book is trying to be very exact. He's telling you let f be the function that is assigned to this, that, which is a very good way of defining a function. But quite often you will not see it this way. In some books, they tell you a certain quantity is a function of another quantity. But how would you understand it? What comes before is a function of is the output, what comes after is the input. That's as simple as that. That's how you read it. Okay. Okay, I'm going to give you another example. I'm just waiting for you a little bit. If those who are taking notes, they have time to take notes. I'm going to give you another example, and I will ask you, what do you understand by it? Okay. Can I move on? Anybody has any issue with me moving on? Put on chat. All right. So example number 2. Let f be the function that gives the cost to produce laptop as a function of the number n of laptop produced. Okay, it gives the cost as a function of the number of laptop. So in this scenario, how do you understand f? F assigns to what? What? It means what should go here? What should go here is a function of. Okay, now back to you. This, what do you think is looking at the input here? And what do you think is the output in this scenario? So the cost, a function of how many laptop produced. So the cost is the output. Absolutely, the input is the number of laptop. So my function is assigned to the number of laptop produced, the cost. That's how you will see the function a lot of time. So let us say I ask you to interpret the following sentence, which is something I do. I'm just going to make up number. F of 40 equal 10,000. Okay. How would you interpret this sentence? The 40 represent what in this scenario? The 10,000 represent what? And how would you interpret? So 40 represent what? Quickly, I'm looking at chat. What does the 40 represent? So clearly the cost is the output, exactly. So 40 represent the number of laptop, 10,000 is the cost to produce laptop. So how would you interpret this? As you guys write it very well, the cost to produce 40 laptop is $10,000. So that's how we interpret that sentence, okay? And a lot of books, instead of being extremely precise by telling you let f be the function that is assigned to this, that, they tell you, okay, let f be, give you the cost as function of that, then you have to understand what's the input and what is the output. All right, so section 1.8 is basically, that's what the section is about, to introduce this new way of, this different way of writing a function. All right. Now we move on to section 1.9 because those are really basically very simple ones, is the idea of increasing and decreasing functions. Okay, so increasing and decreasing function. But before we do that, and decreasing. But before to do that, we're going to a little bit review together what we call like the interval notation. So we're going to review interval notation. And then I go back to define this. Okay. Interval notation. Very good. All right, here it is. Let us say I'm on the number line. I have a number line. And I'm going to pick a number 2 right here. And I'm going to describe, we're going to describe everything larger than 2. All this. Okay, so that's the first example. So 1. I want to describe the shaded region in Word. How I describe the shaded region? I'm going to describe it in 2 ways. First, the question is describe the shaded region. Okay, so in words, because some of you will be more comfortable in words and some of you will be more comfortable in citation. In word, how do I describe it? I describe that everything here is described as all values of x that has the following property. What's property they satisfy? Such that, or that have the property that, such that, what characterize any number here? it's bigger or equal to 2. So in words, that's how we can describe it. Everything in the shaded region bigger or equal to 2. And in this scenario, 2 is included. Okay. Now interval notation. How we describe the same shaded using interval notation. Okay. We say that all values of x in the following interval. How do we describe this? Okay, we put bracket closed 2, comma, everything bigger, as probably you guys have seen that, plus infinity. Okay, this is called infinity. It's not a number infinity, it's just an idea. It's a symbol that tells you everything larger than 2. All right, so it's a notation that it's nice to know. Now let us say I want the same thing, but I don't want 2 in it. So I want everything here, and this is my 2, and 2 not included. 2 not included. Okay, so that's scenario number 2. All right, how we do that? Again, the same thing in words and interval notation. So we know how to do it both ways. In word, I tell you the same thing. I'm interested in all values of x such that, or that has the property of, that's what such that means. It means they have the following property, such that x strictly greater than 2. Interval notation become? Interval notation is the same thing, but instead of bracket, we put parentheses. It means 2 is not included, and plus infinity. Okay. Now, another notation for interval that, again, we have to know very well. So 3 is the following. Okay, let us say I'm interested in the following shaded area, right there. 2 included, I don't know, 5 included. And I'm interested in everything from here to here. This is the area I'm interested, sorry, the region I'm interested in. So how can I describe this in words and then in words? Okay, so how I describe? It means the number, yes, absolutely, thank you. Yes, closed bracket, it means the number included. Open, it means it's not. It's not, it is. It's not, it is. All right, thanks. So in words, all values of x, so these are the notations such that the following. What do we know about x? Any x in here, it's less or equal to 5. And here I will explain. So I'm going to explain here what they are, and then I'll write it. Everything here is x in here is less than 5, and x in here is larger or equal to 2. You agree with me on that? That's what it is. It's less than 5, x, but bigger than 2. So sometimes we combine those with one notation and we write x between 2 and 5. So be very careful with how your inequality works. X between 2 and 5. The largest value that x can take in here is 5, is included, that you realize, and the smallest value is 2. Be very careful with how those inequalities work. So x between 2 and 5. Now in interval notation. Interval notation. It's very easy for that. The interval means, to write an interval, it means all values of x in the following interval. Bracket, close, 2, comma, 5, close bracket. Okay, so this notation, 2, 5, means everything between 2 and 5, 2 and 5 included. So these are the basic notation, and we're gonna have, of course, variation of that. So for example, suppose I write the following interval. Minus infinity, even though I did not introduce it, but intuitively I think you understand it by now. 2, it doesn't have to be 2, let's say minus infinity 0. And I'm gonna break here. What do I mean by that? Minus infinity 0, what does this interval notation? This means all values of x, because it's minus infinity to 0 less than x, such that x less, close bracket, or equal to 0. So on the number line, this is my 0, and minus infinity represents the shaded one, up to 0. Very good. And if I open it at 0, means very easily I am excluding 0 from it. So I'm going all the way up to here. Okay, so there are notation that we should know, and probably most of you know them, but we have to, we have to know them very well. The one that gives students sometimes difficulty, and I tell you that ahead of time, is this one. Okay, because they get confused a little bit about the sign. This tells you that 2 should be less or equal to x, or x bigger or equal to 2, and x less or equal to 5. That's what will this one read. The largest value x can take is 5, the smallest is 2, x between 2 and 5. Yeah. Now we're going to talk about increasing, decreasing function, and as I said, it's not a hard idea at all. Those two sections are simple. So what is an increasing and decreasing function? Remember, function is a rule. You give it an input, it spits out an output. So let that be a function, and assume that the domain is the closed interval AB. So I'm immediately introduce notation here. What do I mean the domain? It means I have a function. So what does it mean a function? We have on the x-axis, these are the input values. On the y-axis are the output values. And the domain, it means this function takes value between A and B. So after that, I don't care about what's happening. That's the domain. Now, what does it mean to say f is increasing? Very intuitively. F increasing means if whenever the value of x, it means the input values increases, it means basically we're moving to the right, because that's how the input increases. The value of f, or the output value, also increases. It means when x gets larger, f of x gets larger. So if it's here, suppose at A, that's the output. As the input gets larger, the output gets larger. As the input gets larger, the output gets larger. That's really what it is. So graphically, it means the function looks like that. That's what graphically it means. It means the graph rises. The graph rises. That's important. As we move from left to right. That's how we read a graph, from left to right, because we always assume the input increases. Graph rises as we move from left to right. Okay, so that's really what increasing means. As the input increases, the output increases. Right? Now, decreasing is what you expect it to be. Decreasing, it means when the input increase, the output start losing values. So let us do that. So this is A and this is B. That's really what my function makes sense. And decrease, it means suppose the function takes this value at A. Decrease, it means as you move to the right, it means my input gain value, my output start losing value, losing value, losing value. It means my function is actually falling down. That's a decreasing graphically. Okay, so it means that f, the graph falls. Always as we move, crucial, from left to right. That's how we read the graph. from left to right because we want x to increase left to right. Okay, so increasing, the graph rises, decreasing, the graph is falling. Finally, when you say f is constant on an interval AB, what do you mean by that? It means f assign the same value to each number in this interval. So f constant, so we have an interval here. This is A, and this is B. If I tell you f is constant, it means whatever it assigns at A is going to assign it everywhere at B. It means the graph is nothing more than a horizontal line on this interval. Okay, and every function is sometimes increasing, sometimes decreasing, and sometimes constant. Every function will have this kind of behavior. Okay, any questions, please, before we move on? So now we're gonna do two examples. The first one is simple. Okay. And then you have a worksheet on Brightspace that you guys will do it together. But first, let's get the everything notation. So I'm giving you the graph of f of x. Means you have a function. These are the input value here. And here the output values put here. And then if I want to know, the rule is for every input, the output is given by this horizontal distance, by this vertical distance. Okay, now the question is, determine the interval on which f is decreasing. Means I want, how do we answer this kind of question? The interval on which f is increasing. And we're gonna write the interval in basically two different notation. So when is f increasing? On which intervals? Any chat, anything comes to anybody's mind? Please feel comfortable. Okay, usually a function is increasing on an interval. So, okay, I'm giving numbers, but let me make very clear, all of us. The function is how we think, how we answer this problem. Where is the function increasing? It increases all the way up to here. Right. It increases. Now I'm assuming the function is defined for all real numbers. So the graph keeps going. Nothing is really stopping the graph. It means the function increase all the way up to here. Now, so this is f is increasing. Okay. Now, I'm going to analyze this graph totally, and then we answer the questions. And then what is happening to my graph? Between 1 and 2, as we realize, between -1 and 1, as we realize, as my input is getting larger, my output is really going down. F is decreasing up to here. Between 1 and 2, okay, we change colors. I think I have another color. Right here, as you realize, the function is not changing values. Everywhere here, it's constant. Okay. And finally, after 2, f is increasing. Okay, so that's how we analyze this. Not at one point. It's increasing on an interval, on a whole interval, on a whole domain. So now how are we going to answer every one of those? And I will answer the questions in two ways, in words and using interval notation to make it easy for us. So I will first do it in words. So when is f increasing? I look at my graph. So in words. So f is increasing is for all values of x that have the following properties. All values of x such that, okay, x here, you can put less than -1 or equal to -1. In this case, it doesn't really matter very much. So I will accept either less or equal or strictly less. It's okay, both of them. But not only that, for all values such that x less or equal to -1 or x bigger or equal to 2. Okay? No, you don't have to list both ways. Is this understood? Now, if I want to write an interval notation, because I think the student would list, eventually a lot of books start writing an interval notation. But I'm going to write an interval notation in an easy way for this. So this is one way you can tell me I'm clear. Another way you tell me is all values of x such that x less than -1, it means x is in the interval minus infinity -1. You can close it because I close it up here. Or x in the interval 2 plus infinity. So there are two intervals, but you have to tell me actually both of them if you use interval notation. Okay. And for some of you that probably they have seen this notation, so I will write it. If you see it, sometimes this whole thing is written like that. There is a sign here like a U, which means union together with that. If you feel comfortable with this notation, it would be my guess to use it. If not, you can write this one or write it in words. But I want you to be familiar with all of them. All right, now, on which interval f is decreasing? F is decreasing only in one place between -1 and 1. So here the question is, so in words, all values of x such that it means that have the properties x between -1 and 1. Make sure this one is the one that all of the time student has difficulties with. Or interval notation, this one is very easy interval notation. You can say x in the interval -1 and 1 closed. The function is constant. The function decreases. Okay, finally, the interval on which f is constant. All right, when is f constant? I go back to my graph. 1, 2, very good. So in interval notation, because it's fairly easy in this case, x in the interval, I always relate the graph 1, 2. I always get back to it in the interval 1. Okay, so it's fairly simple idea. There is not really much to it in terms of increasing and decreasing. What matters is you get the notation very, very clear. On Brightspace, you guys go to Brightspace, all of you, and go to the worksheet section. And there is a worksheet that we will do it together. Go to worksheet. Are you guys with me? And click on worksheet number 5. So you guys, all of it, have it on Brightspace in case this one is not clear. So all of you, please go to worksheet number 5. And for some reason, those are not showing up clear, but so you have them on Brightspace. Sorry. Are you all there? Okay, so I want you to read question number 1. It's simple. And I give you a minute or 2 minutes at most for number 1. And then I pick up your answer. Okay. You guys read the problem? So I'll read it and you have to tell me. It's fairly simple. A hot cup of coffee is put on a table. Let f be the function. that assigns to each time t the temperature of the coffee at this time. So you take a hot cup of coffee and you put on the table. And at every time the temperature is changing, of course, because it's hot and the coffee wants to take the temperature of the room. So is the function increasing or decreasing? So immediately, what am I looking here as the input? Because we have to understand the function. And the question also is sketch a rough graph of the function. And what is the output in a way? So the picture we always draw, that's your function. What are you inputting in here? I want answers, please. So what is f doing? Assigned to time to temperature. Okay, so my input is the time. My output is the temperature of the coffee. Okay, so we input time, we output temperature. Okay, so function increasing or decreasing quickly. Sketch a graph in your mind, or not in your mind, on your piece of paper. How would the graph looks like? Decreasing, Kevin, decreasing, Kevin. All right, absolutely so. Why? If we're graphing, remember when we graph, on the horizontal axis is always the input, which is time, and the output right here, the temperature. So at t equal to 0, it means the minute I got my cup of coffee out of, I've just got it, I just bought it, and it's very hot, I put on my table. So originally it has a certain temperature. As time go by, I assume the temperature of the coffee is gonna go down, and the temperature will go down and down and down. So that's how the graph would look like. As time increases, temperature decreases. As time moves on, the temperature moves on. It will keep going, as your classmate is mentioning on, it will keep on, and eventually till it hit the temperature of the room. And after that, it's just stop. So the temperature will be totally, that's when it eventually the temperature will stop. So the graph would look like that, go down, down, and then it starts changing in a way because it reached the temperature of the room. Very good. Now number 2, again, some questions are old because some students are still having difficulties with number A, and the other questions are the new. So the first question is, again, find, so this is the graph of a function, and I'm telling you the domain is all real numbers. So what do I mean by that? It means that the graph keep extending. So this is a straight line here, it keeps going, it never stops. Of course, I cannot draw it like this, but like it keeps growing, but we're not worried about some of the values. Question is for which, find all number x such that f of x equal to 3. Again, here, I'm giving you the output, you want the input. Okay, so f of x equal to 3, you guys give me the answers because you have the, what should it be? What should it be? That's my 3, that's my output. And I want all the input. But the output is 3. That's 1. The other one, I know that you are reluctant to give me an answer. What do you think? Who can give me an approximate answer? It doesn't have always to be exact, the answer. So one value is very clear. This is a 1. And the other one, who can give me a good approximate for it? It doesn't have to be an integer. What's a good approximate for the other value? Minus 1.5, I will push it a little bit. Minus 1.5 would be here. That's minus 1. That's minus 1.5. So I will say like almost 1 minus 1 point, a little bit to the left of it, something like minus 1.6 or 1.7. I agree with that. Okay, but it's not minus 1.5, it's a little bit to the left of that. Find f of 3. Find f of 3. Here, 3 is the input. Here, 3 was the output. So do not ever confuse those two. F of 3, it means, okay, this is my rule. 1, 2, this is my 3. f of 3, the rules tells me that that's this horizontal, sorry, this vertical distance from here to here. And according to my graph, this is 5 and this is a 6 according to my graph. So this is equal to 6. Okay, now find all the number x such that f of x equal to 0. Again, what am I asking here for? I'm asking for the input that gives me an output of 0. So now the input value. Again, what are the input value? You guys give them to me or write them on your piece of paper. 0 is one of them. Is it the only one, Travis? Is it the only one? No, absolutely not. A lot of you missed that on your quiz. You would give me one value. No, there are two values. There is this one and that. All right, so that's the old stuff. Now the question is determine the interval over which the function is increasing, decreasing, constant. So go ahead, I give you again time for you to totally break up the function into increasing, decreasing, and constant. Remember, the only remark you put on chat are stuff that they are related to the material. Right? So each one of you, please figure it out, and then we will write your answers together. Okay. Yeah, I'm starting to have answers, and this is increasing. I'm stalling on purpose. I want each one of you to figure it out. I want every one of you to get their answers, and then we do it together. Okay, are we ready? Are we ready, yes or not? Anybody on chat, tell me, you ready, yes or not? Yes, Priel is ready, okay. Kayla, very good. Let us rip it apart, like I did in the previous one. If I look at it, the function is decreasing up to here, right? Correct me if I am wrong. So up to here, f is decreasing. Up to here. And this is, according to my graph, is -1/2. And then what's the graph start doing? The graph is rising all the way up to here. So up to here, here, all the way to here, my f is increasing. Right? Now what's doing? On this tiny little piece, here it is decreasing again. On this tiny little interval. And then after that, it takes off. So let me put this in that color. Should have green here. After that, it takes off. F is constant. Okay, so it decreases up to here. Then as the input increases, the value are actually getting larger. Between -1/2 and 0, they are negative, but they're becoming less and less negative. So they are getting larger because they are becoming less negative. up to here, which is, and then decrease and then increase. So that's the picture. Now I go to you. Determine the interval on which f is increasing. What answer do you guys give me? From where to where? Okay, I'm having from, actually this is minus a half, whatever. So let's accept this is minus a half. And all the way, I don't understand your notation. The notation that I see I'm having difficulties with. Okay, up to here. What's this value here? So this is 2. Very well. So this is a half, sorry, a fourth. My apology. A half, 1, 3 half, 2. So every box is a half. So right here, this should be 2.5. Okay. So when is it increasing? It's increasing 4. Interval notation between minus a half or minus 0.5 and 5 halves, 2.5. That's when it's increasing in interval notation. Or of course you can write minus a half, 5 halves. It doesn't really matter which one you pick. Okay. Now decreasing. All of you, right? What I did not understand on Blackboard is on chat 2.5 and 3. So you have to pick up. I think 2.5 is the correct one. The second one, decreasing. And the students are using the union notation, which is very good. So it's decreasing up to minus a half. So one way is from minus infinity all the way to minus a half. Union also is not decreasing on one interval, it's decreasing on another interval. And here I will give you the right to open it or close it because either one will be actually correct. And from here to here, after that, it's decreasing from 5 halves all the way to 3. So I will follow your notation and I'm going to close it because you guys are correct. Okay? Yes. All right? Or you can tell me in words, if you ever don't feel comfortable with those notation, but you should, you tell me all values of x such that x less than minus a half or x between 5 halves and 3. So in word, it means all values of x such that x less minus a half or x between 5 halves and 3. Now, which interval the function is constant? Please, all of you. No problem, Christian. Okay, where is the function is constant? And that's, I think, it's fairly simple. It's constant starting at 3 and so on because my domain, not 3. 3 will not be accepted. Fix it. Not at 3, on an interval because it's constant on a large interval. So 3 plus infinity. Everywhere it's constant. Or all values of x such that x larger or equal to 3. So it's not constant at 3, it's constant on an interval because it's not changing value on this interval. It's constant on an interval, not at a specific point. All right? So this is for today. So the section today are simple, basically more exponent, more solving quadratic equation, a different way of writing a function, and the notion of increasing and decreasing. The last few minutes, of course, all of you saw the announcement on Brightspace. I hope you did. And we will start the online homework. And did you guys read the announcement? Let me take you to it. Sorry. Okay, and I will definitely share it with you. All right. Okay, I will share the announcement. So share screen. I hope, all right. Okay. All right. So instruction for the online homework system. Okay, starting this week, we will be using an online homework system that is a homework assignment, which will be using a homework management system called Moodle. The material for the book that we're using, as well all the homework that you will be doing online, are written by a professor here at Purdue. So it's really, one of the faculty here is doing all the work, for us and for you guys. And there is a document in here that will totally guide you into how to log into the system. Okay, so I hope you guys have done it. I know that some did, some didn't. So let's go through it very, very quickly. Sorry. Okay, how to access the online assignment. You have to go to this website. And that's Moodle website. Moodle is an open source. You don't have enter your name and password, and your username is the same as your PNW username. So it's being very clear. That's your username. Your username is the username for your Moodle. Now, some of you may have gotten already an email from Moodle. So look into your email. If you haven't gotten an email from Moodle, okay, so what you should do, if you haven't created a password yet, check your PNW email for an email from Moodle. If you don't see one, check your spam folder, because sometimes they'll end up in the spam. All right, and if nothing comes up, then go to the website, and it's very easy. You see this thing written. When you go to the website, you see forgotten username or password. Enter your username in the screen. One of the students just did it a minute ago. Enter your username in the screen that opens and click search. And that's when you do that, you will get an email into your email account, and you go from there. All right, so that's how you log into Moodle. And once you log in, I will be assigning homework. Like the first homework I will assign is going to be due like a week from Wednesday, and it's going to cover increasing, decreasing function, and it's going to cover what I will be doing on Thursday, which is the average rate of change, right? So the way I'm planning to do it is that you guys do your homework, your practice problem, let's call them, and on Thursday we talk about average rate, and the following Tuesday we do more problem about average rate. Wednesday evening you will have to the homework will be due, so you will have plenty of time to look at the homework, the online homework, to ask me questions in class, so you can do it. And hopefully on Tuesday, the first few minutes, I will show you a little bit how to use Moodle, but I want all of you by Thursday to log in. And if any of you has really, really difficulties, you just send me an email. I hope you don't have any difficulties with that. Now, this being said, okay, let me stop sharing. All right. Now, this being said, only the online homework will be for grade. I try to make that very clear. Those one will be for grade, and the combined, all of them at the end of the year, I will count them 5% of your grade. Now, I will always be assigning practice problem, like I've been doing since the beginning of the semester. Okay, those will not be for grade, those will not be collected. But as you realize how much, guys, you're learning from those practice problems. Okay, so the way I will be doing it, I'm gonna keep the same thing every time. Like right now, I'm gonna assign problems. Those are practice problems. So you're not due, but on Thursday, you ask me questions about them. And this will help you for your online homework. It will help you also for your quizzes. Okay, so the practice problem, the one I always assign, they are not due, they are not for grade. What's for grade are only the online one. Is that very clear? Assignment 1 is the first one we do today. Yes, but it's due a week from Wednesday. Is that very clear? It's due a week from Wednesday. So you don't have to do it today, because you cannot do it today unless you know the material. Okay, so on Thursday, I will explain what we call by average rate, and then you will be ready to do the homework. Okay, so the assignment is due a week from Wednesday. It's not due this week. What I'm going to give you today are just practice problems for you to learn better and better the material. All right, can you ask me more questions so we clear up any confusion? Yes, everything will be like this. I will always assign practice problems, always, and those are the one we discuss. And the online homework is for you to do, and this one will be graded. All right, any other questions, please feel comfortable to ask. All right, so please log in, all of you, and email me. And remember, you have your quiz on Thursday, and I will explain on Brightspace what would the quiz be about. All right, anything, please, before we finish? Okay, good luck, guys.